Hello everyone, welcome to my lecture video 8. Today we will do the final topic of test 4 and also of this entire course, Calculus 1, which is Newton's method. So as you all know, next Tuesday, 21st April, you are going to sit for test 4, and after that, before the finals, whatever time we will have, we will do review for the finals. That is, we will go through the entire syllabus. So I have already prepared the review for test 4. I'll be mailing you the review today, and also I have also prepared the review for finals, which I'll be mailing you after the test 4 is over, that is next week. Okay, so let's start with Newton's method. Okay, so what is Newton's method? As the name suggests, so this method was invented by Isaac Newton, and Newton's method gives you approximate solution of any given equation. So it gives approximate solution of any given equation. So what do I mean by solution of an equation? I think all of you know. So what do I mean when I say I'm trying to solve this equation? What do I mean actually? So first of all, you consider this equation, say fx equal to 0, where fx is, say, something called x cubed plus x to the power 5, maybe plus some constant. Suppose you have to solve the equation x cubed plus x to the power 5 plus 7 equals to 0. You need to solve this equation. So what do I mean when I say I want to solve this equation? So I mean I want to find out that point alpha such that the graph of the function fx cuts the x-axis at alpha, right? So that means if the graph of y equal to fx is like this, right? And suppose the graph of y equal to fx, it cuts the x-axis at the point alpha. So this point alpha will be called the solution of the equation. So this point alpha will be called the solution of the equation, or the root of the equation. So when I say I want to solve this equation, I basically mean I want to find out the value of alpha. That is, I want to find out that point where the curve cuts the x-axis. So if the curve cuts the x-axis at alpha, this basically means f of alpha will be equal to 0, right? Because alpha is a point on the x-axis. So if the curve y equals to fx cuts the x-axis at alpha, so this means f of alpha equal to 0. So you can also define in that way. So solution or the root of an equation fx equals to 0 is a point alpha such that the value of the function at alpha is 0. So these are the two ways in which you can define the solution of an equation. So when I say I want to solve the equation fx equals to 0, I actually mean I want to find out that value alpha such that f of alpha equal to 0, or equivalently I want to find out that point where the graph of y equals to fx cuts the x-axis. Okay. So what does Newton's method gives us? Newton's method gives us an approximate value of this alpha. Okay. So what Newton's method actually does is the following. We start with some initial guess, right? So we can always make guesses, right? So make any guess. Suppose you take your favorite number, say x0, and it can be anything. It is your guess about the root. So we don't know what alpha is, we can certainly guess the value of alpha. Suppose that guess is the number x naught. So x subscript 0, we pronounce it as x naught. So we want to, so this is our guess. We can always make any guess, so it can be any number. Now what Newton's method will do is that it will take your guess, and then based upon that guess it will provide you another number x1, right? Okay, this number will be close to the actual root or the actual solution than your guess. Okay, then again it will provide you another number which will be more closer to the actual root alpha. So in this way, it will, the Newton's method will give you a plenty of numbers, or in to be precise, it will give you a sequence of numbers x1, x2, x3, and so on and so forth. All of these numbers will, as a train, it will go towards the actual root. So this is suppose the actual root alpha, which we don't know. This is the actual root. So what will Newton's method do? It will generate a sequence of numbers x1, x2, x3, and all of them will just go towards the actual root. In other words, first you will provide a guess. So based upon that guess, I will provide you a mechanism called Newton's method. Using that Newton's method, you can produce another number x1 which will be closer to the actual root than your guess. Then from x1 you can generate another number by the Newton's method which would be even more closer to the actual root. In this way, you will want to generate a sequence of numbers, all of them will be closer to the actual root. Okay, so when we have a sequence of numbers x1, x2, x3 in this way, which goes towards a number, towards an unknown number, we say in mathematical language we have a sequence x1, xn. So x1, x2, in general I can write xn. So this sequence will, in mathematical language we will say the sequence xn. Right, converges to the actual solution or root alpha. So when I say the sequence xn, it converges towards alpha, means it goes nearer and nearer to alpha, or you can say that the limit of that sequence is alpha. Okay, now so how do I generate these numbers x1, x2, x3? That's what we will study. Okay, well, let me draw a graph. Okay, so suppose this is your graph. This is the graph of your function. It cuts the x-axis at alpha, and we want to simply find out the value of alpha. This is unknown. So this is my curve y equal to fx, right? So this is my solution which I want to find out. Okay, so to find out the solution, what we do is we make a guess. So we start with a point x naught. This is my guess. As I told, it can be any number. Let me take it here for you. So I first of all make a guess. Suppose I make a guess. Suppose this is my solution. Though it's not the solution, but I make a guess. I take any number, your favorite number, Then what you do, you draw a perpendicular line, a vertical line, which passes to the point x0. It hits the curve at some point, right? Then you draw. So what will be this point? So looking at the graph, this point will be x0, f of x0, right? Any doubts about that? No, right? So this point will be x0, f of x0. Now, what I do is that I draw a tangent line at the point x0, f of x0. So the tangent line must cut the x-axis at some point, right? So if I draw, so how will a tangent line look like? Draw it. Okay, so I take a point and I draw the tangent line at that point. Okay, so as you know, tangent is a line which cuts a curve at a given point. So I take the point here and I draw the tangent. So it cuts the x-axis at some point. Okay, so this point I name it as x1. Okay, observe that this is my actual solution which I want to find out, and this was my given guess. So given any guess, if you do this process, you get a number which is actually closer to the actual solution than your guess. Okay, then you repeat this process. You draw, you repeat the same process. That is, you draw a vertical line from the point x1, right? It will cut the x-axis, the curve at this point, and then again draw the tangent at this point. The tangent will cut the x-axis at some number x2, which will be, now you see that this number x2 is even more closer to the actual solution alpha. Okay, so you see that from any number x0 of your choice, if you do this process, that is, if you draw a vertical line, if you draw the tangent, it will cut the x-axis at some point x1, and then if you repeat the same process, you see that you can go from any number of your choice to the actual solution alpha. This is what Newton discovered. So if somehow I can find out a formula for these points, that is x1, x2, so then starting from any guess, we can steadily approach towards the actual solution alpha. So this is Newton's method. So Newton's method actually gives you a formula. So putting any number or any guess of your choice, using that formula, you can actually generate these numbers x1, x2, which will steadily approach towards the actual solution. So you will take that you will take that as your solution based upon how much accuracy you need. Suppose you don't want your solution to be that much accurate, right? Then you are satisfied with x1, which is close. Suppose you want your solution to be more accurate, then you go to take x2 as your answer. Suppose you want your scientists who are working in the laboratory, say the scientists who are trying to who are dealing with experiments which requires very minute computations. Suppose a astronaut or a rocket scientist who wants a very high precision. For them, for their calculations, if there is an equation they want to solve, they want their equation to be very precise. So what they will do, they will take not x1 or x2, they will take x100, because these numbers will gradually approach towards the solution. So now what we will do is that we will find out a formula for these numbers, that is x1 or x2. So let's find out the formula. So let us deduce the formula, in fact. So observe that this x1 is the point where the tangent at x0, f of x0, cuts the x-axis. Now what is the formula? We all know what is the formula or what is the equation of a tangent at a given point. So we all know that the formula for tangent at the point f of x0, f of x0 is y equal to f of x naught plus f prime x naught x minus x naught. This is the equation of tangent at the point x naught f of x naught. Okay, so maybe I should write it below so that becomes more clear to you. So the formula of tangent is y minus f of x naught equal to f prime x naught times x minus x naught. So this is the tangent at x naught f of x naught, right? This is the equation of tangent at x naught f of x naught. Y minus f of x naught equal to f prime x naught x minus x naught. You can see, you can check this equation out. It is there in the notes where we studied equation of tangent. Now in this equation, if you, so this is the equation of this line. Now in this equation, if you put y equals to 0, right, you get the point where this line cuts the x-axis, and that is the point x1, right? So if in this equation I put y equals to 0 and solve for x, I get the value of x1. So let's put y equals to 0 here. So in place of y I put 0. So 0 minus f of x naught equal to f prime x naught times x minus x naught, right? Now let's solve this equation. If you solve this equation, you will get, so you will get minus f of x naught by f prime x naught equal times x minus x naught, right? So you will get ultimately x equal to x naught minus f of x naught divided by f prime x naught. Okay. So you just take divide both sides by f prime x naught, and then you take it on that side, you get this beautiful formula. So this is the value of x1. So x1 is given by x naught minus f of x naught divided by f prime x naught. So, and then in the same manner, if you find out the equation of tangent at the point x1 f of x1, so this point is x1 f of x1, if you find out the equation of tangent at this point and then put y equals to 0 in that equation, you will get the value of x2, and you will find out the value of x2 to be in this way: x2 equal to x1 minus f of x1 by f prime x1. Okay, so x2 equal to x1 minus f of x1 by f prime x1. So if you repeat the same process in the same manner, you can also that is, you draw a vertical line at x2, draw a tangent, and then find out the point at which the tangent cuts the x-axis. You can find out x3 and so on and so on. So now so you see that x1 equal to x0 minus f of x0 by f prime x0, x2 equal to x1 minus f of x1 by f prime x1. So in general, you see xn, you can write down the equation of xn as xn equal to x0, xn minus 1 minus f of n minus 1 divided by f prime xn minus 1. So this is the general formula: xn equal to xn minus 1 minus f of xn minus 1 by f prime x minus 1. So putting n equals to 1, 2, 3 and 4 and so forth, you can find out all the numbers x1, x2. Okay, so in your exam, basically you will be given a function fx. You have to repeatedly use this formula: xn equal to xn minus 1 minus f of xn minus 1 divided by f xn minus 1, and repeatedly apply this formula, and then and that's Newton's method. That's exactly Newton's method. So let's do a few problems so that it becomes easier for you. And you see that this gives you all the members of this sequence. If you put n equals to 1, you get the first term of the sequence, you get x1. If you put n equals to 2, you get x2. If you put n equals to 3, you get x3, and so on and so forth. Now in your exam, in some of the problems, you will be asked to just find out the value of x1. Then it's very easy. You may be asked, give me the value of x2. Observe that to find out x1, if I put n equals to 1 here, then n minus 1 would be 0. So basically the formula for x1 would be x0 minus f of x0 by f prime x0. So to find out x1, you just need x0. Now if I put n equals to 2 here, I get this formula. And observe that to find out x2, I need the value of x1. That is, I need the value of x1 which I obtained in the last step, and so on and so forth. Now let's do some problems. So basically, you will be given a guess. That is, you will be supplied with the value of x0. You will be also supplied with the function f. So first, you know x0, you know the function f. So you can find out the derivative, and then you can, using this formula, x1 equal to x0 minus f of x0 by f prime x0, you can find out x1. Now once you know x1, again using this formula, you can find out x2, and then you continue. Put n equals to 3 here, you get the formula for x3, and so on and so forth. So let's take a few problems, and then it will become very clear to you. Okay, so the first problem is this: starting with x1 equal to 2, find the third approximation x3 to the root of the equation x cubed minus 2x minus 5 equals to 0. Okay, so you are given the value of x1 equals to 2. You need to find out the third approximation x3. Okay, so this is your equation. So this is x cubed minus 2x minus 5. So how to do it? We take fx, let fx equal to x cubed minus 2x minus 5. Okay, what you do next? You compute out the derivative of this function. So you have f prime x. So f prime x is what? 3x squared minus 2. Okay. Now you are also supplied with the value of x1, which is 2. So x1 is equal to 2. So what you do? You know fx, you know f prime x, you know x1, you know the value of x1. So you can now use the formula. It should actually be so you can use the formula x2 equal to x1 minus f of x1 divided by f prime x1 to find out the value of x2. So in that general formula, what was the general formula? The general formula was this: xn equal to xn minus 1 minus f of xn minus 1 divided by f prime xn minus 1. So in this general formula, which I wrote down, if you put n equals to 2, you will get exactly this equation. See, because then n minus 1, so n is 2, so it will be 1. So this is the formula which we have to utilize because we are given x1 and we have to find out x2. Okay. So let's now put everything inside. So x1 is given to x1 is 2. So f of 2 divided by f prime 2. Okay. So f of 2, you have to put this 2 in this equation. You get 2 minus 2 cubed minus 2 times 2 minus 5. F prime 2, you get 3 times 2 square minus 2. Then you have to use your calculator to compute it out. So 8 minus 4 minus 5 gives you minus 1 division. Two square is 4, 4 times 3 is 12, 12 minus 2 is 10. So you get minus 0.1. Then you multiply it with another one, so you get plus 0.1. So you get 2.01 as your answer. Okay, so this is your first step. You compute out the value of x2. Now once you know the value of x2, and you can again use this formula. Now I know the value of x2. Now if I put n equals to 3, what do I get? I get x3 equal to x2 minus f of x2 by f prime x2. Right? So now I know x2. I can put down the value of x2 here, and then we can find out the value of x3. So let's do it. So now we know x2 is 2.01. So x3 will be x2 minus f of x2 divided by f prime x2. So it will be 2.01 minus f of 2.01 divided by f prime 2.01. So it will be 2.01 whole cubed minus 2 times 2.01 minus 5 whole divided by 3 times 2.01 whole square minus 2. The top value you get is minus 0.899. The bottom value you get is 10.1203. get basically 2.0988, right? So this is your x3, and that's what you wanted. You were asked to find out the third approximation, and you have find out the third approximation, which is x3. So this will be your answer. So in this way you have to do all the problems. Let's do the next problem. The next problem is starting with x1 equals to -3. Find the third approximation x3 to the root of the equation 1/3 x cubed plus half x squared plus 3 is equal to 0. So this is your equation. 1/3 x cubed plus half x squared plus 3. So f prime x will be 1/3 times 3x squared plus half times 2x plus 0. So you get x squared plus x. And the value of, this is the value of derivative, and the value of x1 is given to be -3. So first apply the formula. So x2 equal to x1 minus f of x1 divided by f prime x1. x1 is -3, so -3 minus f of x1 means f of -3 divided by f prime -3. So this is -3 minus 1/3 -3 whole cubed plus half -3 whole square plus 3 whole divided by -3 whole square plus -3. So it will be So it will be 3 minus 3 plus 0.25. So it will be minus 2.75. And that is the value of x2. Now apply the same formula again to find out x3. So you have found out x2 equal to minus 2.75. So now x3 will be equal to x2 minus f of x2 divided by f prime x2. So x2 will be minus 2.75 minus f of minus 2.75 divided by f prime minus 2.75. So it will be minus 2.75 minus f of minus 2.75 means 1/3 minus 2.75 whole cubed plus half minus 2.75 whole square plus 3 whole divided by, so minus 2.75 whole square plus minus 2.75. So it should be equal to minus 2.75 minus, so the first term is minus 6.93 plus 3.78 plus 3. So minus 2.75 plus 0.031. So you get minus 2.719. So in the same manner, you can do the remaining problems. So there are two more problems left in the exercise, but since these are the same thing, you have to just apply this formula. Basically, for each of them, you have to first compute out fx. You need to compute out f prime x. You will be given x2. You will be given x1. You have to apply the formula x2 equal to x1 minus f of x1 divided by f prime x1 to find out x2. Then again do the same process again to find out x3. So in all the problems, there are two more problems left in the exercise. So use the same technique to solve them, and that's all about Newton's method. It's very easy, very scoring. In addition, so that concludes the syllabus for test 4 and also for the calculus 1. So we are done with calculus 1. So now what you have to do is that I'll be mailing you the review sheet, for test 4. So you have to go through the review sheet. You have to go through all the problems of these 4 chapters, that is inverse functions, natural logarithmic functions, natural exponential functions, Newton's method. You have to do homework 10, 11, 12 and 13, and that's your syllabus for test 4. Do all this, and you can if you have any problems, you can mail me, you can ask me for a Zoom meeting. I can send a Zoom meeting with you. Okay, so now I'll be preparing a review sheet for test 4, and I'll be mailing you the review sheet and also the solutions along with the solutions to you today. So the format for test 4 will be the same as for test 3. I have decided not to change it, so it will be multiple choice questions. So all the best, study hard. And for test 4, so a kind reminder, the test 4 will be next Tuesday at 11 a.m. So at 11 a.m. I'll be sending you the question paper. You have to, in the same manner we did conducted test 3, you have to write down the correct answer is for each of the correct choice and mail me back within 3 p.m. So we'll be doing the same procedure, the same technique, everything will be the same. So I wish all the best for test 4. After test 4, um, we'll have 1 week left. So what we will do is that we'll do review. We'll be doing the review of the whole syllabus. So how we'll be doing review? Either I'll upload one more video, or I will just solve some previous year's problems. So I'll solve say 5 previous years questions, and then I'll mail them to you. So you will have 5 previous years questions completely solved. So it's your duty to go through them, and if you have any problems, you can always mail me or ask me for a Zoom meeting. So I wish you all the best for test 4 and for upcoming finals, and also for your future academic career. Thank you, all of you.